Hi, today we will discuss the solution for the 26th problem of 26th Leetcode problem that is called remove duplicates from sorted array. So what is the insight in the description? Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. The first thing, change the array nums such that the first k elements of nums contain the unique elements in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size of nums. And we need to return k, so number of the unique elements. So how we will solve this problem? So first of all, let's look on the examples. So I would like to use the second example, because the second example has a bigger array. It has a bigger array, and you see, so as input you have this array, and the output you have this one. And here you can see underscores. This means that it is not important what is here, and probably here will be the last elements that were here. So let's copy this here and this and discuss. So how we will do to solve the problem? So we can just go through the array using for loop, usual for loop. And when we see that the current element, for example, the current element differs from the first unique one, so first unique one is 0, and an element on the place where index is 0 will remain here in any case. So the second element that will be unique is 1, so we will just, let's copy this. So 1 will be moved to the second place, to the place with index equal to 1 to 1. Then the next unique element is 2. Previous ones are not unique, so we will do nothing with them. So the first, the next element is 2, so we will just move it here. Then the second 2 remains the same, and we go till the element is 3 equals to 3. And we will do this again and again, and at the end we will have this this array. So how we can behave? So we can store our first unique element in a variable that is called unique, and of course it can be equal to the first array element of the array. And next, that is important here, is that we store our we can store position of the last unique element, and we can use for name of this position we can use k, because k we operate with k in description of our problem. So k, our index of the last unique element, equals to 0. And let's discuss our for loop. So for as usual we use I for as for a variable name. It starts, but it starts, very important, it starts from not from 0 but from 1, because 0 it is already the 0 element on the 0th place is already unique. So to analyze if the current element is unique or not, we can start from the element with positions 1. Then we compare I with size of the array, length, and of course I plus plus. And what we will do inside our array, let's take here just this. So inside our array we compare every current element nums I with the last unique element, and only if it is greater, only in this case we can do we can act. So how we will act, how we will be acting? First of all, we increase k, index of the last unique element. Then we change unique to this nums I element, current unique element, current new unique element, and then we move this element value to our k position of this array, so nums I. Well, actually that's it regarding the algorithm. It's done. But what is important, what we should do more, we should return the value. So let's see what should we return. So we have k that equals to the last index. So in our case the last index is 4. So k will equals 4, but we need to return not like the index of the last unique element, but the number of the last unique element. So we need to return k plus 1. So let's input and check. So let's just take this our code, just a second, let's take it here and wait, I copied wrong. Well, and let's uncomment it. Uncomment. No. Well, probably that's so. Let's check. Let's check if it works. If it compiles and if it works. Compilation error. Well, what is not good here? Maybe like this. Let's check again. Reach time to file by parsing. Well, okay, we haven't closed our for loop. Let's check again. Well, now we can see that it works for the both cases, and we can submit. Let's submit. Well, we can see that our solution beats 100%. Well, that's all. Thank you for, so here is like the algorithm. That's all. Thank you for your watching. Thank you for watching.